Hello and welcome to this playlist in which we will use Unity to create new games and Unity's machine learning agents to train an agent to play this game. So I hope you will enjoy the video and learn something from it. So for today's video we will need Unity. It's open source. I already created a video how to install it. And we will need the machine learning agents from Unity. I also created a video how to get everything to run. And in today's video, we want to take a look at this learning environment, and I will show you how to set it up and how to start the training. But you can also give it any other name. Then you also have to define a directory where you want to save it and just create the project. Once everything loaded, which can take some time at the first initialization, then we will start setting up the environment. But you can also give it any other name. Then you also have to define a directory where you want to save it and just create the project. Once everything loaded, which can take some time at the first initialization, then we will start setting up the environment. Then we have to install the machine learning agents in this environment. I already have an extra video about this, which I linked below. But basically we have to go to the package manager and install the packages from our disk. And I described you in an extra video explicitly how to do this. And if you have watched this, then you can just skip this part. Basically what we have to do is we have to install the basically the latest release of machine learning agents and have to install the machine learning agents package JSON files from the extension and from machine learning agents itself. Then we are good to go and can set up objects. For this we click in the hierarchy on 3D object, and then first of all we click on the plane. We can then transform the position of the plane, the size of the plane. We can stretch it, we can move it around. All of these parameters you can see on the top right of your window, where we can give the different transformations to the three-dimensional object. The plane will be the playground for our agent. And you can just play around with the parameters to find the size which is suitable for your project. Then we can also give this plane a name by clicking on it and then renaming it to floor, for example. And now we want to also add this to a group. For this we have to create an empty project. This will be basically our environment which we create. And now we can drag and drop the floor into this environment as a sub part of the environment. Later on it will be clear for you why we need this environment empty variable. Then we can also add inside our environment an agent and a target, so we can add spheres, we can add cubes and so on. And if you make the plane huge, the objects look very small compared to this plane. So what you always can do is click on an object and click the F key on the keyboard to zoom in. Now we want to find a good position for the cube, and it will be our target. So it should stand on top of the plane. So that means that we have to move it upward. The cube has a size of 1 and it's symmetrically produced around the 0 point. So we have to move it up for half a unit so that it's on top of our plane, which is grounded at 0. Now this target should also obey the laws of physics. So we add a component called rigid body to it, which makes physics being applied once we click the start button. I will show you the example. If I move up the cube and start the game will load and you will see how the cube will fall down. Now we have our target. We center it again on the plane and not above. And now we want to add the agent by adding a 3D object as a sphere. So we want to have a spherical agent. And we are still searching for a name of the agent. The proposals by the community so far are the names Robert, Cubey for a cube agent, and Globy for a spherical agent. If you have another idea, write it down in the comments and we will create a poll to find the best name for our agent. This agent, let's call him for today Robert, will get also a place on the plane. So we have to change the transformation also in a way that we have to lift it up. And we also want to give this agent a rigid body component to obey the laws of physics. And now the fun begins. We want to now give this agent and target behavior. So we go to our assets and create a new folder called scripts. Here inside this folder, we will add the behavior of our three-dimensional objects by creating a mono behavior script. Then we also give this script a name. I call it my agent for now, but you can also give it another name. Maybe it's even good for learning purpose if you name it differently now. Then we can open this mono behavior script by double clicking on it, and this will automatically open Visual Studio Code. This is the editor which we can use for scripting. Inside this editor, you see the class myAgent as a mono behavior script with start and update functions. But for now, we want to delete this and start from scratch. But first, I want to take my time to explain you what reinforcement learning is. In reinforcement learning, we have a robot or an agent inside an environment. This environment we build with Unity. Inside this environment, we have the agent who can use sensors to observe the state of the environment. These sensors then give information to the agent, which the agent can forward to its brain. The brain then decides about an action, and then the action triggers or runs a motor or some other event that changes the state. Once we are in a new state, this state can give a reward or a punishment, which is then again used to improve the agent or the agent's brain to, in future, make better actions. Normally, the agent plays a complete game or episode and collects a lot of states and rewards. And in the end of every game or episode, the brain will be updated or trained. This process is iteratively and repeats as long as the training goes on. And for every step, the Unity machine learning agents environment will give us the necessary tools to make measurements, to perform actions, and to train the neural network. So now let's get started with scripting by using the agent class of Unity. And by the way, if you want to see more of these videos, subscribe to the channel and hit the like button. So first we include all the packages of Unity ML agents, sensors and actuators. Then we use the machine learning agent class for my agent. And then we have to initiate the rigid body variable RBody, which will be our player. Then we also have to define our target, which will be a public variable. And you will see soon what public variable means. Then in our onEpisodeBegin function, we define exactly what is going on when a new episode starts. There we first check if our player, which we refer to with this dot transform dot local position. If the player is below the plane, so in case he was falling down, then we set his velocity, angular and linear velocity, to 0 again, and his start position will be at the coordinate origin, lifted by half a unit in the height. Our height is the y coordinate in our coordinate system. Then we also set the local position of the target randomly in the x and z coordinate with our playground size of 8 from -4 to +4, and we want to randomly place it, and also shift our target by half a unit in the height. Then we define the function collect observations, which are basically our sensors. So we inherit from the vector sensor and call the variable sensor. And there we add the position of the target with sensor add observation and the local position of the target. We also add the local position of the player, and we also add the velocity of the player in x and z direction, so the velocity along the plane. Then in the next step we already have the action of the agent. This is something which is handled in the background, and this action will be saved in an action buffer. So in our function on action received, we basically define what to do with this action. The first thing is we want to introduce a control signal which should control us in x and z direction. So it should go to this action buffer and take the continuous actions, and I will explain this later as well, and use them to define a force that will act on our agent to make the agent move. We want to be able to scale this force, so basically to scale the velocity of the player. That's why we introduce a public variable called force multiplier. It will be a public variable which we can control publicly from the Unity editor. In the same function, we then also define the rewards. So if the player collides with the target, it will get a reward of 1. And if the player falls from the surface, so when the y coordinate is below 0, then the episode will be over and there will be no reward for the player. The distance to the target can be defined as a distance between two vectors. It's the vector of the local position of the agent as well as the local position of the target. And this distance between player and target is set to 1.4 units. And your quiz for the day is to find out why it is 1.4 units and not more and not less. Write it in the comments. And now we are coming to the last function. It's the heuristics method, which we implement so that I can manually play the game and check if everything works in a way as I want it to work. So for this, I create basically also these actions as continuous actions, and I override these actions with input from my keyboard. And this input will be the horizontal and vertical key of my keyboard. And then we are done and go back to Unity, where we can click on the agent and drag and drop our script on the agent. And then on the right side in the inspector, we directly see that new properties open, among others also the script for the agent. There we have the chance to define the public variable target by drag and drop the target on this field, or by clicking on the right side and then choosing our target. The public variable of the force multiplier can also be changed in this field. This will define the speed of the agent. Then we have to define the behavior parameters. There we have to define the name, we call it myAgent, and we have to define the vector observation space. The vector observation space is basically what we define in our function collect observations, and it consists of the 3 dimensions of the location of the target and of the player, which are already 6 dimensions, plus 1 dimension for the velocity of the agent in one direction, plus 1 dimension for the velocity in the other direction, so in the x and z direction. In total, these are 8 components. Also, the components are continuous actions, as we have defined them. So we have 2 continuous actions and 0 discrete actions in our behavior parameters. And now we can just play with it by clicking the play button and moving our arrow keys. And then you see that the agent will move. And when we hit the target with the agent, the target will get a new position. And if we fall from the surface, then everything will be set to the initial values. And now we can just play with it by clicking the play button and moving our arrow keys. And then you see that the agent will move. And when we hit the target with the agent, the target will get a new position. And if we fall from the surface, then everything will be set to the initial values. And this looks good. So let's go to the last step in preparing the training. For this, we go to the Machine Learning Agents website again and check for our training configuration parameters for our configuration file. And we copy them and save them in our file server so that we can have access to them locally. So let's navigate to our assets folder, and there we create a new folder called config. You can also give it another name. Inside config, we want to create a file. This file we call configuration.yaml. And there we paste the parameters and name it myAgent. The rest of the parameters can stay the same. Now everything is prepared and we can open a terminal. Inside this terminal, we want to go to our assets directory and activate our Conda environment. What exactly a Conda environment is, I explained already in my basics tutorials. Check out my channel or the link in the description. There we have the machine learning agents function, machine learning agents minus learn. And this we can use for the training by typing the path to the configuration file in it and by giving the complete thing a name or a run ID. This run ID will be the folder in which all the information from the run will be saved. Here you can be creative or you can just call it a simple ball environment. And then when you have your name, you click enter and then Unity will be ready to start. So when everything worked and you have set up Unity correctly, then you will see the same screen as I have, where it's written that you should start the training by pressing the play button in the Unity editor. So we go to the Unity editor, press play, and then after a short loading time, the agent starts playing. Or better, the agent starts training. And now you also see that your memory usage from the laptop increases and also the CPU usage increases. And then we have a nice training agent. So congratulations if you made it to this step. So now we can interrupt the training. We have trained long enough and we have reached already good values. So we press Ctrl and C to interrupt. And there it's written that the model or the brain of the agent is now saved in our results folder. This results folder is automatically created and you will find it in the assets. So let's go to the Unity editor, into the assets, and then in the assets you will find the results, and there you will see the brain of the agent and also all other checkpoints. And the latest checkpoint will be then saved as the my agent, and it's the brain. Then we can drag and drop the brain of the agent to the model in the behavior parameters, and then we can start the game. Alright, that worked very smoothly to my mind, and now I've learned how to create a simple agent and how to program it with the tools provided by the machine learning agents. In the next video you will learn how to make the environment colorful and how to get a feedback when you fall by having a change in the color of the environment. Then we want to add a larger target with a higher reward, and we also want to learn how to multiply environments in a way that all of them can train at the same time together, which will extremely speed up our training process. And finally, I want to show you also how to get statistics from the training by tracking basically what's going on. This helps you to improve your models even more. So, see you soon! Thank you for watching! And if you want to support me on my journey, please consider to like and subscribe. And if you want to support me a bit more, take a look at Patreon. There you will see videos earlier, and I will upload videos which are too detailed for YouTube. So thanks a lot and see you next time.